something. No. Yeah. So let's start then with R as a programming language. As I told you last week, we're going to be looking into R. Probably no one of you have heard about R before. It is because it is built by statisticians, so people who have been trained on mathematics and statistics and have some knowledge of computer languages. So actually, R was developed. It is based on a different programming language, let's say a previous one, which is called S from statistics, and was developed, I think, by AT&T. So I think in the 70s, in order to be able to do some kind of data science inside the company. So you can imagine that many years ago, it was very difficult to find out what is the logarithm or to work with just a normal matrix. All computers, all microprocessors, all RAMs, they were not really able to work with large amounts of data that may be a database for a specific company. So every time that they have to calculate linear regression based on, for example, the number of chips that are being, they have some kind of defect in a company production, in a fabric, in a fabric production process, well, they have to do this manually. And in order to solve these things, they created S. R as software, let's say, was born in 1993 as open source. It is currently being used and developed not only in universities, but also in private companies. I already told you about the example of my colleague working in a big bank in Frankfurt using R. And it is mainly for research purposes, which is, as you can see, there is some kind of overlap with Python, which is a general purpose language with readable syntax. It was developed in 1991, was also open source, and the idea was to have a kind of language that is useful for the development. There is as you can see here now, there is some kind of overlap, and the overlap has mainly to do with machine learning, but also with visualization methods. If you are thinking on how much people do know R or not, well, it depends. If you are thinking, for example, in general about programming languages, you will see that in 2021, R was ranked as number 9. So then by here of R, of course, with a very low rank. If you compare it to C or Java, of course, you can do many more things, and you will find much more applications of C than of R. Nevertheless, it has been growing during the last years, the expansion, especially because of the leverages related to data science. So if you look into Python, Scala, and R, so 3 different programming languages, environment, let's say, or programming languages that focus on data science in general, you will find that, of course, TensorFlow, for example, has a large number of commits and contributors, but also it's 2.0 had a large amount of commits, and it is very well developed right now. If you look into ggplot, ggplot is very, very nice framework for data visualization. Everything that is in red is data visualization. And it is, I will say, in some things much better than Matplotlib. Well, you have dplyr, which is similar to NumPy and SciPy. And well, pandas. Of course, it's still very, very powerful and has to do a lot with deep learning. You have this mathematics engineering that it is not present in R. So you can actually do some of the things that you can do with in mathematics, let's say, and in the field of data manipulation engineering with deep learning and so on. But R, it is not devoted to, let's say, optimization problems or linear algebra and so on. So it is we are always in the world of statistics. I was looking into the new table of software. Let's see if I can find it. And now R is actually a little bit below. It is on position number 18, but it's still on the top 20, which is very nice. That means that it's very very common to find someone, let's say, in the future in the industry writing in the same language as you, if you already know R. So, important. So what is R? It's an easy question to answer. It's a dialect of S, I already told you, and was developed on AT&T in the 70s. And we will be installing it, so why should we wait? It is funded, the idea of R, actually, R comes with its own console. So if we go to R, so CRAN, it is called, the Comprehensive R Archive Network will be able to already have a look on CRAN R project, how to download and install R. So I'm gonna provide you this link now on the island course, but in the meantime, I'm gonna ask you to go to CRAN R project. I'm gonna also paste it in the chat. Link to R. And I want you, I mean, in the case that you are working in Windows, or for Windows, case that you have your computer right now is Mac, or you're working on one of the different distributions of Linux, let's go for it. You will see that you can download the binaries for the base distribution. So I will go for the last version, I think. You can also go for the contributions. I think that you don't need it, and the R tools. It will be very interesting in the future when you are building your own packages. For the moment, I think that you can go for the normal one. So as you can see, you will have the download version 4.3.2 on Windows. I'm gonna go for them. It is not really heavy. It is only 79 megabytes. And that's one. Well, you can go to the different questions. I am downloading this thing. You can also look into different versions of it. That will be very interesting for you in the future, maybe because you are using a package that hasn't been updated in the last months, and then you might be needing a previous version of R. You can do this here on the previous releases, and then you can choose which one of the previous releases do you want, you might be needing. We usually have a couple of them every year. In this case, you see 4. Okay. Last year we have 5. So in 2021, 5. But usually there's something like 3, 4. Okay. And well, it isn't always interesting to have it up to date. And I will show you it is not a problem. So you can just go for R. Now open it. My computer is asking me right now, are you sure that you want to do this? Yeah, I'm sure. I'm gonna close R Studio in the meantime. And now it is asking me, what language do you want to use? I'm gonna ask, I'm gonna go for English. And what I'm getting right now is the setup information. If you agree with the general public license. So copyright 89, Free Software Foundation. It is open source. It is free for everyone to use. So you should have no problem with it. I will go for the user installation. So I like the normal one. And do you want to customize the startup options? I will say no. I will accept the normal stuff. Select the start menu folder. I'm gonna use that one because it's the one that I have for all my R distributions installed, and I don't need the desktop shortcut. I'm gonna save the version number in registry, and I'm gonna associate R with R data files, which are the file format that we're gonna be using for data objects in R. So hope that you can do the same. Maybe your connection is faster than mine, probably. Then just wait for me 2 seconds and I will be showing you how this thing looks like. In the meantime, wanted to let you know, like, there are many courses online, okay, on R. There are many in Coursera, in DataCamp, in YouTube. You will have hundreds of hints if you just and then R introduction course or R statistics or R data science, R machine learning. So there are many things that you can learn. Nevertheless, many of them, they are unstructured. Some of them are better than others. I can recommend you the course from Penn. But I do think that with everything that we are going to be learning during this course, you're going to have enough in order to just continue learning by yourself, maybe reading some books and following some tutorials. So you don't need to pay for an extra course on R or whatever. So I do think that with everything that you're going to be learning here, it will be more than enough. So now I have installed R. So if I'm right, I should have now R. Installed in my computer. Let's see if I can find it. Put everything open. Yeah, R. It is new, version 4.3.2. And this is it. Do you have the same as me? Yes, no? Do you follow? Yes, that's perfect. Thank you, love. So this is R. This is the R graphical user interface. It is still in German. I can modify this. That they was it? Instellungen. Oh, sorry. No, it's not here. Well, doesn't matter because, well, this is the old version of R. It only contains this is the console in which we can use R as a calculator. 1.3, it is 4. 4 elevate square will be 16. We can also plot stuff. And it will open a new window. And as you can see, so this is kind of old. And um, we are very lucky because there is a company. Well, there is a company called RStudio that provides a better user interface. I started working with this some years ago already, and now I don't remember when was the last time I opened R, just in this user interface. I think that was a long time ago, probably last time I teach this course. So what I propose you is to go to RStudio and download the user interface of RStudio, which is much, much, much nicer. It is called the RStudio Desktop. I'm going to provide you the link also. Also, I'm going to copy the link to the, and provide you the link on the Allen course. Well, and as you can see, so RStudio is used by millions of people. It is very, very handy. It's a integrated development environment. It's a very nice. Yeah, I will upload the slides of the last lecture. Sorry. It is based on R. Actually, it's just like the disintegrated development environment built on R. You can also use Python on RStudio. This is why it is so nice, and it will allow you also to use many different languages on the same notebook. How to do it? So we already installed R. It requires version plus 3.30 or better, and we already downloaded the 4.3.2, so we are safe. And we can now download the RStudio Desktop. In my case, it's going to be for Windows. I'm running right now Windows. Laptop takes 200 megabytes in this case. So I hope that you can also same in parallel. Downloading RStudio. So you don't need to modify anything, just close R and download RStudio. RStudio is for free, the desktop version. They have different versions, okay? There are different installers in case that you are running Ubuntu, Mac, or whatever. You can also download RStudio directly from RStudio. Oh, I have paused. Wow, this is crazy. I didn't know there's so many. So many. That's interesting. Well, I have already downloaded, and I'm gonna open it. The executable. I'm gonna accept. Then what do I have? I'm gonna accept the defaults. Studio Just gonna wait a little bit until we have it installed. If you are doing the same as me, I'm getting rid of my previous installation and installing the new version. I actually got already a message. Can I code R into like Jupyter and Google Colab? Yeah, you can. I don't use Google Colab, and I don't think that many companies will be using Google Colab, especially those that like the data privacy. But I might be confused. I know is that right now there is some difficulties, let's say, from some companies. Like I'm downloading RStudio Desktop. From this link. Which one are downloading RStudio? Can I do Google Colab? So you are going to be learning how to use R notebooks. You mentioned that not many companies use RStudio either. Well, depending on how much companies do you know on the field of artificial intelligence, there might be more than you expect. Also in the field of data science, there might be much more what you might know. But well, maybe you have more experience than me. It is also possible. What we have seen in the past, at least until now, is that companies don't use only one framework, and depending on what they want to do, they prefer to use one or the other. Let's see now how it's going. Almost finished. Perfect. Now I should have now access to RStudio. Yeah, now this here. It is opening. I hope that all of you also have RStudio. Also install or installing. Oh, something is going on. Now. So can you see it, or it is too small? Okay, perfect. It is too small, or can you see it? It is okay. Okay. Well, in case you only have to modify it with Control plus, Control minus. Okay, and let's now try to have a look at what we have here. So what we have is the environment, files, plots, package, help, viewer, presentations, the history, the connections that we might have with a Git, and some tutorials. We are going to be looking into the tutorials afterwards. And what we have also here are the console, the previous console that we saw before, 1, 2, 1, and for square. I think that this is more or less what we saw before. So some of the as you, let's continue. So the code editor, it is not here. In order to have the editor, you will need to generate a new script. Now that we have the script, we have this script here in which we can write down whatever we will afterwards, for example, by copy pasting, add to the terminal, or just by clicking run. Okay, every time I click on run, it sends the information from the script to the console. If I also go I press control and enter, it will happen the same. And it will send to the console the line in which I am. So yeah. And yeah, if you have some strange ideas, like for example, doing a sum of only one element, leaving the second element empty, then R will be still asking you with this plus for the next, so for a correction. And you can, if you press enter, it will give you same answer until you, for example, enter something that makes no sense, and it's going to be telling you, okay, there is an error here. Let's go back to the slides. So we have R Studio installed. It looks much better. Probably yours doesn't look as nice as mine, but this is something that we're going to be looking in a couple of minutes together. So don't worry. Now we have slides. Let's do the following exercise. Let's try to close R, find a package in CRAN, check the vignettes, check the documentation file, check if there is a publication associated to it, open R, generate a new project, install the package, and check if there has been installed loading the package. Well, there's a lot of instructions here, and maybe you don't know what a vignette means and documentation file and so on. So I will try to guide you through all these steps, okay? So that you understand more or less how to find help while working with R. How do we do this? So let's say we are in RStudio. And as we have said before, R, it was very light. It almost doesn't contain much code inside it. It's something like, it is because R, it is only coming with basic packages, okay? In this case, if I click on global environment will be the environment in which I am working. And I will have additional environments for the different packages that have been already installed and are loaded into this session right at the beginning. So if I move, for example, to the package stats, I will be able to find all the values associated to that one. If I move to the package base, I will find all the values, all the functions, everything that is related that exists in that specific environment. If, for example, I want to look into the package databases, which are the data sets that are coming together, that are inside R as a default in order to work with it, like to provide some examples, I can, for example, look into, okay, let's look into this Volcano. What is it? Volcano is data, actually. I have clicked into it, and now I have information about Volcano. Volcano is a numeric matrix containing a specific number of columns, a specific number of rows. I can visualize it by clicking here, visualizing. You can see it is very smooth. RStudio is relatively fast. Last time that I was using Spyder, it took me it wasn't like that fast as I think that RStudio is. Volcano show us, okay, we have data for a number of columns. We have how many? 50, 61, and 87 rows. And what is it? You might be asking, like, how can I get help? So we can just ask for what I'm looking, what is Volcano, and I will get information about topography of what kind of data set I'm looking. It is opening on the help file. So help, you can ask help just with the symbol. It contains a matrix with 87 rows and 61 columns, rows corresponding to grid lines running east to west and columns to grids running south to north. From which volcano? Maunga Wow in Auckland. Pretty nice. So it also provides me some additional information. I can actually plot it very nicely with field contour. And this is exactly the example to do it. So let's run this. Like, let's see, what do we have here? I'm gonna take everything. I'm gonna say run everything. And look at this. This is the file contour map of the data that we just had a look. So you might be asking yourself, okay, but this data is not relevant for me or whatever. Yeah, it is data that usually it is used like a toy model, a toy data that you can just modify and test your data or your algorithms with. So if I go back to the global environment, the global environment is still empty. I don't have the data. I was working in a previous environment. So if now I'm on the volcano and I go for data, I have a function which is called data. It's loads a specific data sets or list the available data sets. If I go just for data, I will have a list of data sets in packaged data sets. Is Volcano there? Yes. So let's open it. I want Volcano. And now I'm using quotes because Volcano is a word, it's a string. So now I have Volcano in my global environment, right? I can call it, open it, view it. I'm gonna close here. Okay, now you might be thinking, okay, that's great. So it looks like very intuitive, and this is why I wanted to introduce you, like the different console, the environment, the help, okay, the viewer, so that you plot, so that you start understanding, okay, what is going on, why do we have all these different things? Now you know a little bit more on why. So I was telling you, like, it is actually possible to install additional packages, so that you don't only need to work with these packages, but additional packages. And usually, if you are thinking in Python, or you might be thinking on GitHubs and so on, in R we have, of course, also GitHubs, but together with GitHubs, what we have is the CRAN. I already introduced it before. And CRAN has the R homepage, which, okay, there's some news. We can see the R blogs, the developer page. There's a mailing list. Very interesting for those who want to continue developing and using R. But most importantly, I think what is interesting is the R journal. It's a very nice journal in which you can find different papers on packages, on new packages that are being published a couple of times every year. These, of course, are very specific. Yes, it is fine. So you can see there's a very specific Gaussian mixture model in R. So maybe you don't expect to understand everything that it is going on here. Nevertheless, just wanted to tell you, like everything is peer reviewed, so you can be completely sure that all these packages are stable, work, do the things that they claim to do, and are developed by researchers working both in industry and universities. I was telling you, like, okay, but what we wanted to do is find a package in CRAN. So how do I find a package? Actually, you can find a package by maybe reading an interesting paper, okay? Like a package for computing the composing the mutual information index of segregation, whatever it is. Or you can just go to where is it? No. Okay, oops. Modify this or one second. Are not the manuals, are not the books, but there are many. Some of them they are online. I will introduce that later. Of the web. This is why I didn't find it. So there are many different packages. Contributed packages, yeah. Let me see if I can find out the link. Did I? Strange. Run our project. Task views. Okay, this is what I wanted to look into. The task views. That's it. So in the task views, what we can see is the CRAN task, open task, and ongoing task or closed task related to different topics. The idea is that the different fields of research that are related to statistics or data science in some ways, they will be here listed. For example, we can see, I don't know, machine learning, if you want. And then you will see like there is a person, Torsten Hortram. He's responsible for this. And there are some packages that have been already implemented, that have been already proved that they are stable, that they work, that they are able to be used in industry, in research without any problem. So you will find a task open to, or a specific one to neural networks and deep learning, TensorFlow, of course, VCCP for C++, you have H2, so it's H2O, field for neural networks, deep autoencoders. Yeah, there are many things. So you have random forest, regularized and shrinking methods, boosting and gradient descent, simple vector machines, Bayesian methods, everything. Okay, so and what you sometimes want to do is find out if there is something that might be interesting for you, a specific graphical models, for example, GGM, fitting graphical Gaussian models, and I can look into which kind of information do I have from this. I have a manual. Do I have which versions do I have? From which R does it depend? And so on. So you don't need to download it from here. The interesting thing is that in case that you want to install a package, you have two options. One is to write the code, install package, and then you can just select the name of the package that you want to install. Or you can go to Tools, Install Package, and then install from which repository do you want to do it. It can be a repository acronym, it can be a zip file that you have downloaded, package names, and what do you want to install it. Yeah, that will be it. I will install now a package called Squirrel. Like this. And as you can see, what is happening here in the console is that the same code that I wrote before, install packages, is being fit. So I have already the libraries will in my environment. So not in my environment, but install, download it, and now I can call it library. And now I go for, what is the name? Squirrel. And now it is telling me, hi, I see that you have some variables saved in your workspace. To keep things running smoothly, I recommend you clean up before starting Swirl. Type ls to see a list of the variables in your workspace, then type remove list equal ls parentheses, so to clear your workspace. Type Swirl, again, function when you are ready to begin. As you see, so fine, we have completed it. So I have open. Now I can go to Swirl. Also here, like this. And I will see like it has a URL, it has some kind of materials, it's about teaching statistics, I have a reference manual. So I can find information on all the topics documented and on all the functions that are here. Just for you in order to understand how to get help. Now, we have seen before, like we have all the basic operators in R that we know. And I think during the course we already talked about it. So 1 + 1, 2, 3, 28, and so on. So no need to go through all this thing. Important is that the index starts from 1, not from 0. Some packages come with data include. Null doesn't mean that it is not missing, it's just that it is nothing. NIN means not a number, and it means that there is a result, but we cannot represent it. And NA explains that the data is just missing for no reasons. We don't know what's going on. There is no data. Variable assignment. How do we do it? With an arrow. We assign the string apple to the object A. if we print A, it's going to be apple, the output. So we do A is an apple. And as you can see, I already have a value, which is apple. If I plot A, I got apple as output. Yeah. If I will be the same as hello world is and it's already doing the autocomplete for me. What we saw before is that we can remove them by calling them. I get rid of them. And I can create a variable equal to 16.6, and I can create a variable b, which is going to be equal to a, or it's going to be not equal, but it will be linked to the same. Now I have two different values, scalars, so numbers, here that are assigned to those specific names. If you want to remove everything that we have generated, you will need to use the remove function. Yeah, and then we have list equal to ls. What is ls? Let's try to find out. So we already know what remove is. Remove is going to be eliminating one or one specific line, whatever it is we provide, whatever object from our global environment. So we know that remove is remove objects from a specific environment, right? What is ls? ls is the function that allows me to list all the objects on the environment in which I am right now. I am in the global environment, so all the objects, all the list of objects is that. And then what is list? Equal. List equal is one of the arguments of the function. Okay? Of the function, not RLS, but of the function RM. If we go to RM and we see the arguments of RM, you will see that you have list. It's a character vector naming objects to be removed. And actually what we have from ls is a characters vector, okay? Return a vector of characters string, giving the names of the object in the specific environment. So what do I have here is just nothing else than a function saying, I want to remove something. What do you want to remove? Well, I want to use one of the arguments, this list. And this argument is asking me, okay, you can provide a list of things that you want to remove, right? And the list of arguments, it's going to be ls. So we are going to be asking ls to provide this vector to that specific argument, and remove is going to get rid of all of it. And now everything is eliminated. If I close here, environment is empty. Did you follow until now? Do you have questions? Okay, now there are many different functions that you can use, right? So you can use the length function, you can use the sort functions, you can use the order functions. You can have here a view of some of them, useful functions for vectors. You can see you have most of these functions are very easy to understand because the name of the function already explain very well what it does. For example, the var computes the variance. SD compute the standard deviation. The mean computes the mean. You have the length, you have the reverse, the sort, the order, the head, the max, the mean, which max, which mean, and so on. These are just some of them. There are many, okay? How do they work? Well, you can see the examples here. So we can also do our own examples. So if we have a variable x equal, well, actually this is when things start to be interesting. So until now we have seen that we have we can use R as a calculator, in which, and what do we see are these elements here. So we have the element number 3 or the 7, but actually we can generate vectors. So these scalars are vectors of size 1. What we can also do is generate a combination, yes, combine or concatenate different elements. We concatenate different elements, for example, a concatenation of integers. It's going to be A, and it is here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I can do with these elements is calculate the mean of A. I can also see what is the length of A. I can see what I can sort it. Yeah, and this is everything that we have seen before with these different functions. So I think that is enough from my side to telling you stuff. I think that you can already start doing something by yourself. So can you please assign to the object x and y 2 vectors with the following values, 10, 20, 30, and 40, 10, 15, 40, and 45, and calculate the variance of x and the variance of y without using the functions standard deviation or variance? So what do you need if you do this? So let's see. I'm gonna do like this. So what do we need? We need a vector x, which is equal to what? Or it's bounded to what? To a vector x. It's a combination, it's a concatenation of different numbers. And another one, which is gonna be y, which is a concatenation of other numbers. Right? And I want to calculate the variance, which would be very easy, just to like this. But I have to write the form. I have to find another way to do it. Another way will be, I know that variance is equal to the standard deviation of A, right? There's no, but I cannot use the standard deviation neither, so I have to calculate it by myself. So what is the formula of the variance? So what is the idea of the variance? So the idea of the variance was, I want to know what are the errors of a specific sample. the sample variance. And the sample might be X. So what are the errors of measurements of X, taking into account that the expected value is the mean. So what I need is X minus the mean of X, right? And that should be a square. And what I want to do with this, I want to do the sum of all of them, right? Because I want to know what is the sum of all the errors. So actually it will be like 10 minus the mean of X plus 20 minus the mean of X, and so on. And actually, I will take this. I have to square it, right? So is there maybe a better way to do this? Is the sum, which is the summatory. The summatory of what? Of the squares, of the errors squares. As you're doing this, I hope that you are doing the exercise. Someone has a result without asking ChatGPT, because I completely understand that you can ask this thing to ChatGPT, and ChatGPT will give you a very nice answer and very fast. But sum of a square minus mean. No, can someone provide the code, like the code of that you are writing in R? And if let's see who is the fastest. Or let's do something else. I'm gonna give you 1 minute more, and we're gonna see how many of you already finished. So you can more or less know how fast you are in comparison with your classmates. So calculate the variance of X and Y without using the functions standard deviation or variance. The function of the variance you already know. From last lecture. And in case that you need it, I can provide it to you. This one. Get this. So I want to know now, give me an okay in the chat if you already have the answer, please. I already have it. How many of you already have the answer for the variance? No one. Okay, then I'm gonna give you 1 more minute. And a hint, the only functions that you need are this one, and this one. Mean is gonna be equal to what? And I can add comments. Length is equal to n, the number of elements in the vector, right? Danke, Jimena. That's right. Assume is gonna be what? Okay, let's mean. Wait. The mean. No, but this is not. So wait, before you start sending me the message with your answer, okay? Just think that the variable that this is the this here, this is the variance function, okay? This is the function that already can do the job. It is going to be calculating the variance of x for you, right? So what you can do is to find out if var of x, it is equal, and here you can introduce your formula, let's say. So there are some people telling me, what is the variance of x? Yeah, I mean, you can calculate this very easily. I mean, you only need to run this, right? The variance of x, like this. You just run this line, Control Enter, and you will have the result. It is 1.66 and so on. This is the result that you get. I mean, I don't want to share with you this is the result that I get. But how do you calculate the var by yourself? Someone with an answer already? Okay, Wagner, thank you. Well, that's interesting. You're not very far away. It looks nice. let's see what do we have from here. So I have a sum of x minus sum of x, but here, why do you have the sum of x minus the sum of x? The one is the mean. This is the mean, right? It's the arithmetic mean. Now you have x minus the mean of x, right? Jimena, you're almost there. You only need to find out what happens with the denominator. And you have to do the summatory, not the mean. So what I want to do is to do some. Let's start from scratch. There, like what I need is a mean. I mean the mean of x, right? And I need the x. If I plot x, I'm gonna get this. Or maybe let's do it. Because if not, let's do this. If I run x, you see, I get all these things. So if I do x minus mean of x, what do I get? Each one of the elements minus that element, the scalar, the mean, which is a vector with one element. Now, if I do this square, what do I get? I get those squares. Okay, that I'm going in the right direction, isn't it? Because if I look at my formula, this is more or less what I need. I need the sum of the errors, the sum of squares. Do you remember the SS we saw last week? The sum of squares, the sum of squares of the errors. And now I want to sum all of them. Okay, what is the sum of all of it? It's going to be the sum of all those elements here, right? It is here the sum of all the elements that we just calculated. 500. Okay, and what I need to do now is to divide all these things by n minus 1. But I don't know what is n. I know n doesn't mean anything here. I know that length of x is going to be my n, and I have to do a minus. What I have is 124. What is the variance? Still the difference. So what is the error?
We should make a bracket to length minus 1.
To this one? Or to this one?
Yes, here.
Okay, because if not, we are going to be dividing only by the length and then doing a minus 1. So actually what it was happening is this is what we were getting, and then we are doing this object, let's say, this thing minus 1. And this is why we got the 124. This is same as this. The moment where we get this thing. Oops. we get our answer. Oh, okay. Okay, so do you understand the answer? Everyone? No? Yes? I want to see as many yes as possible because I cannot see you and I don't know. Sometimes when we are on the at the lectures, I'm asking myself. Okay, that is nice. Very nice. Okay, now we're gonna be doing the following, okay? I want you to install, I want you to write down the following. Install packages, and then write Swirl. And we're gonna press Control Enter. I cannot do it because I already have uploaded it. So I cannot do it. But I want you to do this thing. Just copy paste if you want. It might be asking you from which package. From which repository do you want to, or for which server or whatever? You can use the one in Regensburg. It's the closest one. Can you give me a yes if you have already done it? And it is installed and everything, and you get an okay, not an error. Okay, one yes, done, thank you, perfect. Now we can write down the following. We can write library, and then the name as well. And it will tell you Swirl has been packaged. So it is here as well. And now we can do, we have probably a, we can write down as well function. What is the Swirl function? Okay, Swirl is a package for learning, okay? It's part of the tutorials that you have here. I think that they are done with Learn R. Okay, it is very, very similar. And Swirl was it's one of the, I think that it's one of the nicer ones, okay? So it's gonna be asking you questions. I'm gonna be following, introduce you some of the operations that you can do with R and some of the functions, some of the stuff that we can do. It is asking us, what shall I call you? And I'm gonna ask, I am God. Before we begin our first lesson, first of all, you should know that when you see 3 points, that means you should press enter. Okay, continue. And as you can see, it is going to be asking me stuff. Let's go on. You can, now we are inside the environment of Well, and this is why we have this way of getting the information. Usually that doesn't happen a lot. Let's get started. We have some information. Okay. I want you to do to install the course number 1, R programming. Now I have R programming gonna use it. And I want you to do to complete the blocks 1, 2, 3. Do you understand? So I want you to complete the exercises 1, 2, 3. How do you do that? You go to exercise number 1. And you will, every time that you will be pressing enter, you will get 5 plus 7. What I want you to do, and now if you are doing this thing, stop and listen to me for 1 second. Okay? Listen to me for 1 second. So I want you to look into your script, okay? Like this script maybe that you already have. It might be here. Yes? I want you to take notes. If you don't think that you might be able to remember, just please take notes, okay? And for taking notes, you can just add notes as comments, or you can just actually write as you want, okay? It doesn't matter. So just don't do the exercise and just do the exercise. I want you to do the exercise and take notes. Okay.
Sorry, but how did we install the R course?
Sorry?
How did we get the R course?
In Swirl. Yes, I will repeat it, okay? 1 second.
Thank you.
So I'm gonna install package. I'm gonna install Swirl. I cannot install it because I already have it. I'm gonna open it. This is what you already have, okay, in the chat. And now I'm gonna use the function Swirl, which I already provide you in the chat. And I have the prompt. It's gonna ask me, what should I call you? I'm gonna tell him I'm Pedro Jose. Thanks, Pedro Jose. That's your cue to press enter, continue. I press enter. Select 1, 2, or 3 and press enter. I press 1 in this time. Let's get started. Please choose a course or type 0 to exit Swirl. Probably if you don't have a course, you will have to press. Sorry. Okay. No, too bad. Okay. When, and then here you can just choose 1. So enter. It will gonna be asking you, please choose a course or type 0. And our type was 1, R programming, the basics of programming with R. And then I decided to start with these 3 different courses. Did I answer your question?
Yes, thank you.
There is the student asking me what notes should I take. My answer is take notes that allows you to remember functions or information that you might be forgetting. that you might think, okay, this is new for me. This is something that I didn't expect it. Because if not, you will have to do the SWIL exercise again, or asking ChatGPT or whatever, and that would be much easier if you already write it down by yourself, because writing down stuff allows you to memorize things. Okay, now let's do a break, 15 minutes, and we will be back. If you want to continue working on this, let's work on it, but let's do a break. See you in 15 minutes. So let's learn a little bit more about Unique. So assigning, you already know how to do this. And we're probably gonna learn now how to look at the object that we have generated with the alias. Next, with the environment. Now we can have a look at it. We can list all the files like this, which are the files that I have generated. In this case, you probably have others. And I can do the dir in also to have the same. Now it is asking me to find help, which I already know how to do it. And the help is going to be provided in the help window. So you can find stuff here also. Okay, and then you can find in that specific topic. So in that specific. Arcs of RM was what we were looking before. In this case, we are going to be need to look into the arc function of list files, and list files is a function. So you have the path, which is everything that it is written here. The pattern, the all files. These are all the arguments. You already know arguments of functions because you have been working probably on other computer and programming languages, so that's not new for you. So alt there, it's going to be equal to what? To set PD. On standard right. Get then. If it is not set, it's going to be get. Now we have the old directory here. And you see that the old directory is going to be just being used as a way to move from one place to the other when you are working with different folders. And well, we can create a directory, under directory in the directory in which we are. It's going to be, and if we go to the environment, to the files. It's gonna be this one. Why was having the problem with the quote marks? Because test this is not an object, it's a character, it's a string, and I need to provide it as a string. So I did understand it's gonna be a name. So now we're gonna have to set VD and test this. And test this, again, it is not an object here. So I have to provide maybe a path. Doesn't like it. Then we have to provide a name. Now it works. Well, it is some publicity about RStudio. Now we can create a directory called mytest.r, use the file create. So I want to create a new file. And what kind of file is this file create? It is a script. Again, I need, that is going to be a name. I need to create it. True. Was it? It's an R file, which is the same as this one. If I want to save it, I'm gonna save it as example2 inside the same directory in my test. You will see this example2 is R, point R, is a script. I'm gonna have to remove that file. I'm gonna do it manually. I'm gonna remove the file, example2. So that I don't have problems with WordSwell complaining about not having the right threshold. I'm not gonna close it, I'm gonna save it. But this one, I'm gonna just continue for the moment. Use file exists. And now my test. Well, how to do it when you are looking through, that will be like many examples you will have in the future, like you don't want to do one thing, only one file, but on multiple files. You can get the information on file info. And what we can see is that we have stuff in my test. So for example, you can do my test and go to dollar, which allows you to go to each one of those different things. Like if you go to size, you have a 0. If you go to, let's see if we can get to, if you can get to C time, you will get to C. File rename will be just providing the previous name. And now the second argument will be the new name. It is always a little bit boring, but you have to provide always, also by writing CSVs and all these things, always the extension, okay? If not, it's not gonna be working. And of course, operating system will provide you simple tools to do this, but usually you are running loops or you are going through different folders with different files, things that are happening in different moments in times, inputs and outputs, things that you are also going to be eliminating. So it might be that you are working on a pipeline in which you generate some kind of, for example, tables for specific reporting for visualization of data, or intermediate steps in which you have to copy the data or modify the data in some specific ways, and then you will want to eliminate it. So how can you do that? Yeah, I'm not using the slides. I'm just using the R. So how can you do that? You create your temporal data folder, and in that temporal data, you start to save everything that you need. And once you finish the pipeline, you can eliminate everything at once. Okay, now we're going to do the copy. It's the same, isn't it? Like we're going to be copying what do you want to copy? I'm going to copy my test2.r, and where do you want to copy, or how do you want to copy it? My test3.r. If this is like this, is this true? It is working. Now you have two files in the same query. It might not be very interesting, but working with dozens of millions of individual files, that can be very nice. Many files will be utilities. We're almost finished. Provide the relative path to the file my test by using file tab, file path. I'm just doing the exercises with you so I know how much time does this thing takes. And I make sure that either you are doing it by yourself, either you are following me, and the problem is the quotes. You can use file path to construct file and directory paths folder that are independent of the operating system. Even was something wrong. mm, not very sure about this. Path folder 1 and folder 2 as arguments to file path to make platform. I don't think that this is going to be working. Because I could somehow. Oh no. For direction create. A character vector containing a single path name, the tiled expansion, paths, character vectors containing failure directory paths, warning, recursive, and mode, use mask. Everything looks fine. Create a directory in the current working directory called test directory 2 and a subdirectory for it called test directory 3 in one command by using directory create and file. Okay, so dir create, and we want to test dir 2 for this. We need this thing. And path is a character vector containing a single path name, which is not sure if this is going to be working. Director create, file path, and recursive has to be passed as through so that one is inside the other, which is this one. So I create a new directory with the file path test directory and test directory 3. If I don't do the recursive, probably it's going to be generated 2. So I have to do it recursive, so it does understand that I have to create a first one, which is test directory 2, and inside that one, the test directory 3, right? And I think I have in that working directory equal to what? To old directory. And old directory is a variable. It's not a character. So is everyone following what's happening? So as you can see, file path to here in folder 1 and folder 2. So Amar, what is going on is that let's This is why I want you to take notes. So we have directory create. This create is a function to what? To generate sorry, I have to correct this. A new directory. Path. Point. File path. Is a function that allows to a specific path for a directory for a file. And now, answering your question, what we are doing now is file to path from components. So if I have, for example, file path, and I generate file path like new folder, and I run this. Sorry, have to eliminate this. So we are generated a new folder, new subfolder, path that we did before. Direction create file path like this one. And now what we want to do is doing it records. It is not just printing it, but we want to generate a directory based on that specific path. So what we do is to generate a test directory number 2 with test directory number 3 inside it. So that they are generated one inside the other. So I take this. And I'm telling it with recursively. Where were we? File path, okay, this is wrong, just was doing something. After you finish this lesson, delete the test directory that you was left, and everything we did would remove directory. Would you like to receive a credit for completing this course? Okay, so the next thing, you can go to yes, and then what is your mail address, and I will do like this. This is my token, and it doesn't work. So you don't need to do any Coursera. So this the Swirl method has been out there for some years, and now the person who invented it, they have generated these Coursera courses on top of it to get some money. Okay, but Swirl is older than that, so you don't need to get any points or whatever. Okay, now you can complete the number 3, R programming. Number 3, sequence of numbers. Sequence of numbers in R is very easy, like from 1 to 20 integers. You can also try strange numbers, let's say. So What? To 10. And now it was going to be augmenting in units of 1. If you go in the other direction, you get something, but crazy. Again, so you have questions about functions, you can get them here. Column operator. Sequency, sequence is also interesting. I use it a lot when I'm working with sequential data like data from smart meters and stuff like this. You can do the same as before, of course, but it also allows you to decide, like for example, by what. Like you can go from 0 to 100 by 0.3, and then all the thing. Yeah, and if you just do whatever this wheel is asking you to do, then of course you will have to set the same answer. Now the length, it's also interesting because if you set the length, instead of using, it's like what we saw last week with the histogram and the different scales, the variable, the length of the bar in the histogram, then you can do exactly the same. So for the class, so you can generate the class as you want. So in this case, it's asking me sequence of initial, final, pi, or length, and the length will be saying like I want actually 30 numbers. So now you have, well, it's not a MySec. So in order to build classes, you can also just decide if you want to have the sequences. So a sequence that is going to be having the same distance between one of the other, or if they're going to be modified. You are using the same functions here, but changing these arguments. I don't know what's going on. You are close. MySec. 5. You got it right. Of course, the length, we already saw it today. So it is nothing new for you. MySec. In other words, we want a new vector. Well, and it's very easy. There are several ways we can do that. Actually, I want to be using length as I used before. Do you remember when I was calculating the length in order to know what is the n for the variance? In this case, it's going to be MySec. And then sec has, maybe I will do this before. I want to go here, and then you can see like the different arguments along with take the length from the length of this argument. So I will do say length it's gonna be a sequence along with. And now always take into account that the argument, if you are providing the name of the argument, you have to provide the equal to. Yeah. MySec is not a character. Yeah, it's an object, so I can identify the object. I don't need to write here the quotes. So I have a sequence, but I can of course say, okay, that sequence was from 0 to minus 30 or minus 20, whatever. Okay, it's also possible. The sec alone function is a variation of the sec function. Try sec alone MySec to get the same result, yet another way. Okay, sec alone here is the same as along with. But here, what we have is a function. What is the function? Well, there's often several approaches to solving the same problem, of course. Particularly in R, simple approaches that involve test typing are generally best, but depending on how the function has been written. And here's something interesting for you. So there is a new movement of people writing code in R and developing packages that try to get really very efficient packages. You can look at them in RStudio. There are many and very, very nice. But it is true that all old functions might not be very performant. So yeah, that's for you to know. So sometimes you want to go for a specific package, so there are many different packages that do the same thing. You have to find out the one that is doing it in the same way, in the better way. So repetition is not the same as sequence. So I'm going to repeat a vector that contains 40 zeros. So I want a 0, right? And I want it 20 times or 40 times. I can repeat a sequence, yeah? Also, repeat sequence. In this case, instead of repeating a sequence, we are going to repeat a concatenation of things. I can, just to make it a little bit more interesting, I can do a concatenation of characters. It doesn't like it. And you can repeat times 10 each 10, for example. Not exactly what we wanted, but also possible, just combining different arguments in the same function. So I hope that you also finished, everyone finished. It was very easy. Do you have comments for me, questions? Nothing. Okay, so base R. Let's go back to the slides and let's see. So now I want you to do the following. This is sometimes very useful. I want you to go to History tab, try to find out what the History tab is in RStudio, and select one or more of the lines that you will find there, and use the button to source to copy it to your script, in case that you have a script up. So sometimes this is very handy when you are trying to write functions and you have tried many different things, And at the end, you will find out, okay, I'm going to keep this and the other thing and get rid of the rest. But you don't forget what was that you were doing. So you just go through the histogram and then the history, and then you will find it. Things that you can do and I think that it is interesting for you. So I recommend you to go to base R and provide a default working directory when you are not in a project. I want you to unclick the restored most recently opening project at the startup, so you don't open always the last project that you were working with. It can be a little bit annoying that you every time that you open you want to start from scratch. You don't want to start from a specific project that you were working the day before or 1 hour before. Restore previous open source documents at the startup. Maybe you don't want it, you don't need it. Why should you be looking into previous scripts? I will also untick it. And then the workspace restore air data into workstab as the startup. I don't think that you don't need it either. So just leave it as it is here in this picture. Also, use native file and message dialog boxes. We will recommend that on the advanced. And what else? Yeah, I have another exercise for you is that maybe you want to change the appearance. So you can go to Tools, Global Options, Pane Layout, and then you can modify how do you want to have your panels. Yeah, and what do you want to see, and so on. So things that are sometimes interesting is to have here the environment history and the console there. That can be very, very handy. So that you don't have to look always to the corner of your screen. Yeah. And for appearance, just follow the same instructions, so you can just go for the appearance. I had this one or the other one, doesn't matter. Whatever you find nice. When you are working on the script, you can control F to run the line in which you are. You can, Control Enter to run the line in which you are in that specific moment. I saw it you before. Control F will be for finding, and Control Alt P, it's for running the last thing that you were running. Okay, the last line, the last command. It will be running like the previous one. This is why Control Alt and the previous. Of course, you can run the entire script by clicking the source button on the top right, or select section of your script with the mouse and click run. I show you already how does it work, like this. For example, now I can do Control Enter. I can go to run here. So on. Yeah, like this. This. Let's think about what happened before, and well, just for you to know what we have done before. I think it is also something very specific to R, from R, that you might would like to know. We can install the library Lobster first of all. Library Lobster. I already have it. Okay, in case that you don't have it, install package Lobster. Okay, that will be the command that you need. Start writing by yourself, so you don't need to copy paste it from me. In case that you need it here, and then you can just run the Lobster. Now it is already loaded into our current session. So now what we can do, and this is why we wanted to open it, is let's say that we have, let's see what do we have in the environment. Now the environment is here. We have A. You can see A is the vector that goes from 1 to 0, right? What we can do is to find out what is the address of that object. The object address of A, it's this, right? And if I create a new object, B, as I told you before, it's going to be same as A. I have it here. And if I ask what is the object address now of that object B, what do you think it's going to be? Well, it's going to be the same because they are actually both looking to the same vector. The vector didn't change. I have a vector. In this case, X, it's going to be bind to the vector C1, 2, 3. So I have vector 1. So I have the element 1, the element 2, and the element 3 in binded to the object X. When I bind X to Y, let's say, what I'm binding them is through the vector. Yeah, so both of them are actually bind to that specific vector. And if I modify, and this is the interesting thing, once, not only in the moment, let's look into what is inside B, for example. Inside B, I have the object number 1, but I also have the object number 3. What is the, I want to get the objects 1 to 7. Here they are. So do you understand? So when I'm looking, I can be looking into this block here. I can select, try to find out what is the element. So for example, you have really an element that it is X. And I know that this X, I'm going to be indexing into the element 2 to element 3. I'm going to get the 6 and the 8. I'm going to be looking into this area here, and I'm going to be looking into element 2 and 3. Now I can be looking into only element 1. So only inside that one. And then I will do something else. So if I modify actually that element, like I'm doing here, I'm saying I'm now taking X, and inside the X, element 3, the third element of X, so 8. I'm going to modify it. I'm going to enter now 89 or 98. I'm modifying it. I can see it here also. And if I look at the object address of X, now it is different. So it is creating a new object on the copy, yeah, of it. And when I modify it, only on the moment when I modify, I generate a copy of it with the new modification. So you already have seen this. So there are some things that doesn't work. It is case sensitive. I use point for decimals. Here are some of the math functions that we have seen today. You are going to be looking in, or we're going to be looking into the next days, but some of the ones that we have seen during the course. It was a little bit difficult for you to understand some of them during the course. I hope that now it is much easier. You remember the mean, the problem with the plus, and when R is ready, actually you will have the simple working directory. We have done the 3 approach. So this is something that I'm going to provide you with the slides, but you already know how to get help. And now what I wanted to talk with you just before the end is the scripts in R. So until now, what we have seen are these scripts that are very ugly, that are called point R. And there was a question for you, like, can we work with Jupyter or something like this? So actually, it is very possible. We don't call them Jupyter. We call them R notebooks or R markdowns. I think that they are much better. The title for this one is going to be lesson for a lecture. One, I'm going to be the author. I'm going to put it in a HTML form. Yes, why not? And now what I have is a title, lecture note, Javier Valdez, date, output HTML. I don't want just to focus too much on this. I wanted to let you know is, well, the options for all the chunks are set to true, which means that we can see both the data and the output, and we can use Markdown, okay, in order to format our work or scripts, everything that we are writing. How do we do that? Well, with R Markdown. Our Markdown file is going to be generated an RMD document. This one, I can save it. I'm going to private lecture. One. Lecture one RMD, right? This is the document that I generated. This thing on the top, I'm not going to touch it for the moment. I mean, it is possible to modify and there's modifications there, but what I'm going to do is just to provide, for example, headings. So the headings are in Markdown are like this, subheading are like this. And the heading how to plot. Plotting in R is very easy. In order to generate a chunk of code, so a chunk of code means part of the document in which you can introduce code, and the R is going to understand that starting from here to here, everything that it is inside this code that it has to interpret and has to provide you with a solution. I'm going to, for example, plot. Yes, plot is a graphic function. I'm going to plot X. I'm going to plot X. I'm going to plot also here my sequence, something that we generated before. I can run this Control Enter. I'm going to do Control Enter. In this case, I have 3 points. Plot, sorry, what is? It is here. Yeah. In case that I'm plotting on directly on the terminal, it's going to be directly on the plot, right? It's a little bit different. But if I'm plotting directly on the Markdown, I'm going to get the plot together with my code. So what it is interesting is that sometimes you want add some in one you see on plot. And there is some errors. You can use bold. You can use also italic, strike through, superscript, subscripts, bullet list, number list, and so on. So there are many many other things that you can do. You can see the examples based on this input. And I'm plotting here this one. There are other kind of plots. You can plot two things on the same chunk. Now I have a histogram and scatter plot. And if I'm gonna knight on save, I'm gonna save it, which means that every time that I'm saving it, I'm gonna run it. I'm gonna commit it, render. Yeah, we don't have X. What's a small error? Let's modify this. Let's see if I can just provide an example very fast. And that will be everything from my side today. I have some homework for you. I'm gonna upload some exercises. I'm gonna try to find out what is going on here, and then provide you with the example. And what I want, what if we delete object P? Andrew, you made a question. Well, it is here. If you want to generate an object inside of P, then you will not have any more a vector, but you will have an array or a list, depending on what you have. But it is possible. And if you put a vector inside a vector, then you will have a bigger vector. I'm going to provide you with exercises that I want you to go through them. And next week we will have the presentations. And afterwards, we will be looking into the different data structures. It's going to be a little bit more theoretical so that you understand these questions, Adri. Like, for example, how to modify a vector and go from a vector to a matrix, and how to modify a matrix in a way that it becomes a data frame and so on, and what will happen if you modify things in different ways. Do you have questions? No questions. So if you delete P, you will still have here. If I remove B, I still have A. Yeah, and the original address of A is the same. So I will repeat. Yep. And this is what I'm changing the value inside B is the same as we have done before. B no, it is modify. But if I do this, and now I do this, it modifies. Well, if you don't have more questions, I will provide you with some exercises in order for you to gain some knowledge. So, do you understand why you need to learn the syntax of the programming language that you are working, even if you have ChatGPT? Tell me yes or no. Why? Why do you think that this is necessary? Better understanding? No, it is not better understanding. It is because ChatGPT might provide you with errors, actually with things that theoretically they do whatever it is doing, whatever you think that it is doing, but actually it is not doing what you want. And you get an output, but you cannot be sure if that specific output is what you expect. So you actually need to understand the language in order to refine, modify, improve everything that maybe ChatGPT is telling you, okay? Because ChatGPT might not be giving you the perfect answer. Same with Copilot. Copilot might be providing you with some hints, but at some point you're going to be doing stuff that it is completely new and no one has done it before, or it is different, difficult, and you will not have a direct answer in Stack Overflow or Change Overflow or whatever. So Reddit, whatever you look for answers. So you need to know the syntax. You need to understand where to find help. How does the thing work? If you don't have any more questions, thank you very much. I see you next week. Bye.